Good afternoon, ladies and gentlemen, and welcome to the Introduction to Chemistry series. In this video, we're going to talk about density. Density is a property of matter, of how heavy or how massive an object is compared to its size. Density has the equation mass over volume, m over v. The most common units for density are grams and milliliters, grams over milliliters. The density equation here shows us that density is what we call an intensive property. It doesn't matter the amount, the number is always the same. For example, we have mass over volume. Let's say the density of water is equal to 1 gram per milliliter. If I go ahead and use that as my ratio, 1.00 grams per milliliter, and I have a mass of 100 grams. If I was to solve for volume, multiply both sides, I get 100 milliliters. You'll notice that if I go ahead and multiply this by 5 on both sides, you'll notice that both of them are going to go up, giving me 500 grams over 500 milliliters. This is what's commonly referred to as a direct relationship. One goes up, the other goes down. Likewise, if I divide by 2, I get 50 grams over 50 milliliters. Or again, if I divide by 2 one more time, I get 25 grams over 25 milliliters. Like I said, this is a direct relationship. Likewise, as we mentioned a moment ago, this is an intensive property. It doesn't depend on mass. If we look here at our two samples, assuming these are both water, 100 mils over 100 grams is a density of 1.00 grams per milliliter. On the other hand here, 500 milliliters divided by 500 grams is also a density of 100 grams per milliliter. The overall point is the density remains the same even though the size increases. That makes it an intensive property. Density can be solved for different variables, just like any other algebraic expression. For example, if I multiply both sides by volume, I get mass is density times volume. If I divide both sides by density, I get volume is mass over density. As you can see here, I can plug in for any of the variables and get a result. For example, let's say I have a mass of 52.9 grams and I have a volume of 91.6 milliliters. To find density, I go ahead and start by writing the density equation, mass over volume. I then plug in the values, 52.9 grams over 91.6 milliliters. I then solve. 52.9 divided by 91.6 is 0.58 grams per milliliter. Make sure you round your answer to the correct number of digits after the decimal place. In this case, we generally round to 2 or less after the decimal place. Let's talk about the units for a moment. Here, you'll notice the units are grams on top and milliliters on the bottom. You not notice that I wrote it as grams per milliliter. Either method for writing it is perfectly fine. The traditional method or the simplified method. For our next question, I'm given the density of a material called aluminum, a type of element, a metal. The density of aluminum is slightly less than the density of water, 0.900 grams per milliliter. That, by the way, means it'll float on top of water. We have a volume of our aluminum of 152.9 centimeters cubed. That means aluminum is a solid, not a liquid, which is pretty normal for all metals. We know from our discussions previous that 1 centimeter cubed is equal to 1 milliliter. So I can use that in milliliters. Using our equation here, we have mass is density times volume. Plugging in density, I get 0.900 grams per milliliter times our volume, which is 152.9 milliliters. We now get into the first example of units cancelization. It's easier to see if I write it this way, grams over milliliters. When I go ahead and I solve, multiplying 0.900 grams per milliliter times 152.9 milliliters, I get 137.61 grams over milliliters times milliliters. You might notice that the milliliters are at the top and bottom, so they cancel. That means I have a final answer of 137.61 grams of aluminum. Notice quantity, unit, and label. Likewise, I can also solve for the volume given the mass. Here, the volume of aluminum is going to be mass over density. Now, this leads us to an interesting situation with the units, which we'll get to in a moment. Plugging in our values, we have 59.6 grams, and we have 0.900 grams per milliliter. You'll notice this gives us a compound fraction. When we divide the two numbers, we get 66.22 grams over milliliters. Let's address the units. Grams over milliliters. If you multiply by the reciprocal, which is how we deal with compound fractions, you get grams times milliliters over grams. These guys cancel, and my final answer is 66.22 milliliters. A quick shortcut for this: if the problem is solving for volume and you use the appropriate equation, just get the final answer, the units of milliliters. That'll make sure it gets solved. This has been our video presentation on density. As always, if you have any questions, ask your teacher or message here. Have a great day, everyone. See you later.